if I understand the question, it says that you are learning data science, that you continue the data science first before you move to machine learning. Yeah, continue learning your data science, but in reality, data science, yes, is often done. You can finish the entire idea of data science within 1 or 2, 3 lectures, depending on what they are really teaching you. However, the hardcore of real data science now, the best way to handle data science is machine learning. So any data science course that does not include machine learning may just be, I don't really know what they intend to gain, because when you talk of data analytics now, we have different levels, 4 levels of data analytics, which is under data science. We have predictive analytics, which is the power, you can use the power of machine learning. We have descriptive. Descriptive data analytics is the only one you can do without machine learning. Yes, you use statistic, main, media, visualization, do a lot of visualization. That is, you are asking what happened. Now looking at the raw data, what has happened, and you're analyzing it. That is called descriptive analytics. Those are the data science application in this present age that you can do without machine learning if you want excellent or good results. Once you are done with descriptive analytics, then you move to predictive, then diagnostic. Diagnostic is after predicting that something may go wrong. You then ask question, why will it go wrong? So that you can fix those things that is making it to go wrong. For example, you identify that a student may drop out of school. You then ask the question, why will it drop out? Then you'll be able to identify maybe where he's staying. People stay in that street. People stay in that particular hostel. Last time they drop out. People with these characteristics, they drop out. We'll be able to investigate and take preemptive decision to prevent the student from dropping out. And so also applicable in other applications. And the last but not the least is prescriptive analytics. This is when you want to achieve a particular target. It's like optimization stuff. I want this kind of sales to be achieved in so month. Then the system will now do a lot of optimization and tell you what you need to do to achieve those targets. So all the major part of data science analytics today, you need machine learning, especially when we go to big data. When you do big data, I gave example today where we're talking of data in motion. At that point in time, you can't do without machine learning anymore. So you need machine learning as soon as possible. And the good news is the approach I use in my machine learning thought is we do more practicalizing machine learning using data science. Data science is not machine learning, like I mentioned. Data science came far before machine learning. But the coming of machine learning has made data science very sophisticated. So my advice is, don't worry, continue with the course you are taking. Watch those videos. You also see data science being mentioned continuously in those videos. So we interface machine learning and data science in our own training. So when you watch those 7 videos as a newcomer, the first 4 teaches you introduction to machine learning. Even inside it, we mention a lot of data science. So it's interwoven together. And by the time you're going to practicalize in Weka, it is purely a data science work. You only use the machine learning algorithm to do the data science job. So the two can go together. Don't say I want to start learning only data science. When I'm done, data science is big. It may take you a long time. Maybe what you are doing with the machine learning lawyer, you do it faster and better. And when you move to big data, which is part of data science, then you can't do big data without machine learning, because that's the only technology that has ability to model data that is in motion, moving data that needed to be processed. We can't use statistics at that point in time. So at that point, machine learning becomes more compulsory for you to learn. So that's why I recommend learn it from the simple video we provided. By the time you watch them next week, by the grace of God, come up with your questions and clarification, and hopefully that will be better and easier for you to be able to take decision finally. Thank you. It says if I'm working with a data set that contains missing value and requires some basic cleaning or minor transformation, how should I proceed? Should I still prioritize letting the data speak first, or is it acceptable to perform this necessary preprocessing? Thank you for that question. You see, when you say let the data speak, you see, if you have data that has missing value, even with that, you can still do modeling without processing the missing value, without treating the missing value. If you want to use decision tree algorithm, when you pick decision tree algorithm, it has the capacity and capability to model data in the presence of missing values. So use decision tree and see what you can get. However, if you want to use k-nearest neighbor or support vector machine, it will generate error if there are missing values. So at that point in time, it becomes compulsory to treat missing value before you start your modeling, because you want to try several algorithms. Decision tree and its family, random forest, all the families of decision tree, they can work with missing value without any error. But other algorithms may not be able to do that. So we can say that the only preprocessing that is almost compulsory, but yet I say almost compulsory because it's not compulsory for decision tree. So we can say almost compulsory for other algorithm is missing value treatment. Any other transformation, please avoid it. Use the raw data as much as possible. Then you create that one as first pipeline. Pipeline 1, raw data. Pipeline 2, missing value treatment. For pipeline 1, you use decision tree only and its family. Pipeline 2, do the missing value and bring in other algorithm. Pipeline 3, do other transformation you want, one by one, please, so that you'll be able to know which transformation will work for you. Because when you do transformation 1, transformation 2, and 3 together and you run it, it may not work. Maybe transformation 1 was good, second was good, but the third one destroyed your data. So you need to be able to separate the good from the bad. So you can only do that when you have multi-channel approach to data processing. So use them. Transformation 1, run the algorithm. Transformation 2, do the modeling, another channel. Combine transformation 1 and 2, do another channel. Transformation 1, 2, and 3, another channel. Transformation 2 and 3. So this is the way you go gradually, increasing your transformation processing steps until you make sure that you have let the data speak, and then you can select the final one that gives you the best result. It may be the original data. You may not tell. A lot of data science people always believe their data is dirty. You can't get good results. But we've had several practical cases that after all the transformations we did, we went back to use original data and we got what we are looking for. So this is the principle we explain in that book called Let the Data Speak. Thank you for those questioners and also for everybody for participating. So it's time to call it a day. And by the grace of God, see you again next week. Thank you very much.